Welcome from San Diego, California. We are reaching you in English, Spanish, and Portuguese live through a unique and complex international telecommunications network via satellite, microwave, and cable. The International Training Center at San Diego State University brings us together once again through this original video conference program, which joins distinguished organizations representing education, business, and government in Mexico, Cuba, the Dominican Republic, Costa Rica, Panama, Colombia, Venezuela, Peru, Ecuador, Brazil, Bolivia, Paraguay, Argentina, Spain, and the United States of America. We acknowledge the participation of the Organization of American States in Washington, D.C., and the United Nations Conference on Trade and Development, UNCTAD, in Geneva, Switzerland. Distinguished experts join us today to examine the topic, the emerging global superhighway, Internet, World Wide Web, satellites, and applications. This is the 6th video conference of the year 2000 series on global strategies for excellence, value, and optimal performance. My name is Farhad Saba. I'm Professor of Educational Technology at San Diego State University. Today's program will be composed of 2 presentation modules and 2 question and answer sessions. We look forward to your live participation through this program. We seek to provide some insight on what the role of the emerging global superhighway is in today's economy and society, and more importantly, in your organization. As Internet developments sweep over the globe, the convention of electronic networks formed by connecting computers has become the most critical and fastest growing component of our economies. In essence, the network has become the computer. This network is cable as well as satellite, linked, multinodal, and multimedia in nature, and it is increasingly becoming multilingual and multicultural. The global superhighway is now truly a fast developing worldwide network for communication and collaboration. For example, the networking equipment market has been growing 26% a year globally, and companies like Cisco, which represents about 20% of the market for routers, have joined the ranks as the most valuable corporations in the world. Nowadays, you solve an organization's networking problems, and oftentimes you find that organizations grow immediately. At the same time, the world is demanding a better global network and a more efficient Internet, particularly for video applications. We all know that the Internet was not designed to carry broadband content, and consequently, we have all faced the reality of faulty webcasts and unacceptably slow downloads. Delivery of the Internet via satellite represents a new broadcast backbone through which we exchange content globally. It accelerates delivery and greatly improves viewing quality by bypassing congested landlines. Sidera, Tachyon, and other service providers are now expanding worldwide, creating new markets to facilitate multitasking and solve regulation hurdles via satellites. This is but one of many developments in this incredibly new technology world. Today, telecommunication systems are changing how we learn, how we work, and how we live. In most countries, millions of dollars and countless hours have been devoted to computer literacy. Telecommunication literacy, however, is as important as computer literacy. These two forms of knowledge combined create a new discipline, that of digital literacy. In today's digital information environment, telecommunication networks are becoming more sophisticated in order to offer integrated services carrying voice, video, and data combined. What's more, they enable us to use various application software from different manufacturers over a seamless network, a network which combines various carriers, technologies, and services to transmit text, image, and voice throughout the globe. Learning about how today's telecommunication environment works will ultimately save you time, money, and effort in providing the necessary services within your organization and to your clients and customers. Our guest experts today will provide you with the necessary initial information so that you can take advantage of the enormous capabilities of the global telecommunication network. Mr. Jeffrey Smith is the Chief Executive Officer of Virtual Integrators Incorporated, a firm dedicated to its partnerships with key information technology companies in providing full service turnkey integrated solutions to the Internet marketplace. He has over 30 years of experience in the design, development, management, and marketing of communication and information systems, products, and services for both government and commercial applications. Prior to founding Virtual Integrators Incorporated, Mr. Smith was both Chief Technology Officer and Vice President of the Telecommunication Systems Group for a major defense contractor specializing in large multimedia, multi-vendor applications running over a variety of government and commercial networks. Mr. Smith's broad professional background includes design, implementation, and management of information technology for SAIC Net, as well as other enterprises such as a 200-office, $2 billion per year corporation, a crisis management video network facility for a classified customer, as well as for the Intermediate Nuclear Forces INF Treaty Verification Network. Mr. Smith holds a Bachelor of Science degree in mathematics from University of California, Los Angeles. Dr. Kambiz Mahmoudi is a global communication consultant with several decades of experience in broadcast communications. He has been in his current position since 1994. Previously, Dr. Mahmoudi served as the Secretary General of the Asia Pacific Broadcasting Union from 1977 to 1980 and Deputy Director General of the National Iranian Radio and Television Network from 1968 to 1977. Dr. Mahmoudi has written and translated several books on the subject of broadcast communications and educational television, and he has taught for several American universities as well as for Tehran University, where he received a J.D. Dr. Mahmoudi holds B.A. and M.A. degrees from Chicago University and a Ph.D. in communication from Indiana University. Welcome to you both, and thanks for being with us today. I'd like to begin with a question. If I may, seeing how the Internet has changed the way we interact, learn, and do business together, and how this network spans the globe via satellites, what do you consider to be the most important contribution of the technology and its widespread use and application? Are we doing enough through education at all levels in schools and in universities to democratize its access and productive utilization?
Well, I'll start with that. I think that the educational community needs to do more. I think it's the basic use of the network in terms of the basic functions such as electronic mail and that are understood pretty much worldwide. I think a lot more needs to be done in the areas of long-distance learning, continuous education brought all the way to the desktops around the world, and to do a lot more in terms of providing available applications over the web, such as you're now starting to see emerge in America, such as e-business and e-commerce.
Thank you for your answers. Let's begin now with Module 1, in which Mr. Jeff Smith will talk about recent developments in the World Wide Web and the Internet.
Thank you. Today I will be talking with you about my favorite topic, Internet and the World Wide Web. During the 1990s, we have witnessed a revolution in communications technology that is significantly affecting our daily lives and how we conduct business and research. Most of us are familiar with fax machines, which have allowed us to send hard copy documents and messages to anyone, anywhere in the world. Now we are able to do these types of communications in electronic format without the requirement of a fax machine or a hard copy device. In addition, you are not even required to know where the person is or his or her phone number. All that is required is an electronic address and an internet connection for your computer. And you are a participant in the global information superhighway. We will be talking today about the backbone to this global information superhighway, known as the Internet. That is evolving rapidly into a global electronic communications media. The applications are virtually endless, limited only by the ability to provide enough communications bandwidth, that is the currency of telecommunications, and end-user equipment to support these new applications. We will be discussing such emerging technology, such as the next generation of the Internet, wireless applications, and desktop video applications. I'm sure that you will all have lots of questions about these new developments, and I look forward to responding to your inquiries during the question and answer session that follows. Now let's get into the technology that is changing our world. Most of you by now are aware of the Internet and some of its uses, but the current common uses for the Internet are only the beginning of what is about to happen in cyberspace. The Internet will soon provide far greater transmission speeds that will allow for truly multimedia communication over the net. This rapid increase in bandwidth will accelerate the development of our global village and will provide a much greater diversity in applications and access. Along with the increase in speed, there will be a convergence of media technologies using the net. For example, televisions of the future will become integrated devices that will support web access, video streaming over the net, video conferencing, and high-definition broadcasts. Digital cellular phones are even now starting to be used for not only voice communications, but for web access and email. This bandwidth increase will be accompanied by an accelerated rate in the release of new products and services. All one has to do is attend one of the industry trade shows, such as Internet World, to be amazed by the latest developments of not only the major players, but of the plethora of .com companies introducing new products at an incredible pace. As a side note, I attended the first Internet World in 1995 at the San Jose Convention Center. There were 6,000 attendees and 50 or so companies represented. By comparison, 200,000 plus attended the 1999 show in New York, and there were hundreds of companies represented. All of this development and growth will require the Internet to expand its capacity significantly within the next few years. This requirement has led to a development of the next generation Internet being sponsored by the National Science Foundation and other governmental organizations around the world. What is the next generation Internet? Well, for one thing, high-speed backbone connections used by the Internet service providers, that is ISPs, will provide up to 66 times more bandwidth capacity per backbone connection than the current ISP network. They will operate at speeds up to 3 gigabits per second. To support all of the new enterprises and organizations joining the Superhighway, a new addressing scheme is required. The current scheme is a 4-field IP address that looks something like 256.567.240.92. It has served us well up to now, but with more people signing on every day, it will not be enough. The new address scheme will support 6 fields for an IP address. As a result, millions more new users can have addresses in cyberspace. Local area networks are now being installed that can support gigabit Ethernet. This increase in LAN speed will facilitate high-speed internet connections and provide a mechanism for enterprises to receive multimedia delivery to each and every desktop. These LANs can be interconnected to form intranets for large multinational firms or extranets for communities of interest. In a way, the International Training Center is an extranet using satellite-based video communication. When it is delivered via the internet, it will become a global university extranet. Until recently, the primary mode of internet access was the telephone line. However, that is now changing also. High-speed internet service offerings are available through cable companies, and soon will be available through wireless service providers as well. What does one need to position an enterprise or an organization to take advantage of this surge in the World Wide Web development? The most important computing device on the net is the server. These can either be Unix or NT-based multi-user systems that are used for hosting websites and web-based applications and cost from $5,000 on up. Larger sites spread their computing power and user support across several servers, which are clustered together and known as a server bank. When you land on a .com or .edu, you are landing on a server. To accommodate the need for speed, the servers are increasing in power at an exponential rate. These servers can operate at over 1 gigahertz per second clock speed and are equipped with gigabytes of rapid access memory and online disk storage capacity. These servers will house the multimedia applications that you will be accessing through the high-speed internet connections. Routers are the devices that transmit information to the specified IP addresses throughout the internet. When you click on a Uniform Resource Locator, URL, you are actually selecting a domain name that has a 4-field IP address. The router sends and receives to the specified address much the same way that you do when you address a letter and send it to the post office. The router serves, in effect, as an electric post office. Router manufacturers are getting ready also for the increase in speed. They will have to be able to route the traffic at the speeds required by Internet 2 and support the 6-field network address translation. Routers start at around $1,500 and increase as one increases the number of ports and the desired functionality. Connectivity to the Internet is provided by Internet Service Providers, ISPs. These providers may be Tier 1 backbone providers like UUNet, PSINet, etc., local and long-distance phone companies such as MCI WorldCom, and Pacific Bell and cable companies such as Cox at Home. From the enterprise standpoint, these carriers provide a number of important services. They facilitate high-speed LAN internet connection, provide website hosting and email services, and may even offer an outsourcing function to co-locate the enterprise resources at the carrier site. This co-location feature is particularly useful for organizations that do not have senior technical staff available to manage their internet applications, or a facility available to house the servers, routers, and security equipment necessary for an internet application. The carrier can provide a complete data center facility with 24/7 network and server management, 24/7 technical support, and asset protection. In this model, the enterprise has outsourced the IT infrastructure but retains management of the content of the websites, databases, and software. A new expanded feature of the ISP outsourcing model is the Emerging Application Service Provider, that's ASP, approach. ASPs partner with ISPs to provide a complete turnkey solution for an enterprise that wants to conduct business using the Internet. The ASP provides not only the managed facility, including IT assets and security, but develops the websites, web applications such as electronic storefronts and business-to-business data integration. The ASP provides all of the custom software development and commercial software integration as well. As a result, the enterprise can focus on what it does best, which is conduct its business online. It should be noted that there is another connectivity source that helps hold the Internet community together. This service is the management of all of the domain names in cyberspace and is provided by Internic. In effect, Internic is the traffic cop of the Internet. To set up a domain name in cyberspace, one must obtain a valid registration from Internic. How is that done? Who manages it? Internic is managed by Network Solutions Incorporated, or NSI, which is a subsidiary of Science Applications International Corporation. NSI has the exclusive contract to register domain names on the Internet. To obtain a domain name from Internic, one must visit the Internic website known as www.register.com and follow the guidelines for registration. The first important step is to check the availability of the desired domain name. If it is available, one can proceed with registration, which now costs only $35. The suffix portion of the domain name that an organization is given is determined by the type of organization one belongs to. For example, EDU indicates an educational institution, such as a university. LIB indicates a public library. ORG indicates a non-profit organization, such as the Red Cross. NET indicates that the organization is an Internet service provider, such as UUNet. GOV stands for a government agency, and the now famous .com stands for a commercial enterprise. The costs of high-speed connection are also coming down to incredibly reasonable rates that will also contribute to a much richer experience on the net for a larger segment of the world's population. For example, a 500 kilobit per second cable connection costs around $39 a month in the United States, with an additional $7 for each desktop included on the local area network. Digital subscriber line is being provided in California at a rate of under $50 a month and approaches nearly 1 megabit per second. Organizations deploying these technologies are already most likely participating in the multimedia digital experience. Even the standard dedicated T1, that's 1.544 megabits per second connection, has dropped to below $1,000 per month. Slower speed modem connections over the standard analog phone lines are still the medium of choice for much of the world today. Most ISPs are charging in the range of $20 a month for a 56K modem connection. Wireless modem connections are more expensive, but they eliminate the need for infrastructure, and they support mobile access. The cost for this service ranges from 20 to 30 cents per minute. Thus, this service is more like an internet messaging service than a standard connection. One of the beauties of the internet is that it is uncensored, free expression of online participation. In many ways, use of the network mirrors the human experience. However, there is a lack of cohesive policy for management and development of the network, and other than some basic domain name taxonomy, some unwritten rules of the road, and some basic transparent communication protocols. There are very few guidelines as to how to connect and present enterprises to the network. Issues relating to copyright, software piracy, pornographic materials, and electronic commerce are already making their way into the court system. Last but certainly not least are the issues of security. Many internet users who are not running active viral scan programs have had the joy of downloading a virus and trashing their machines. Countless stories appear in the papers regarding hackers who invade the privacy of the internet resources and end users. Professional electronic criminals and spies are out there trying to steal credit card numbers and conduct industrial espionage. Users need to be vigilant in protecting their enterprises with firewalls and authentication procedures. Along with developments in high-speed phone lines and cable technology is an emergence in wireless internet access. This emergence is being facilitated by several key wireless standards. One of these, GSM, which stands for Global System for Mobile Communications, is a digital cellular radio network operating in over 200 countries worldwide. It provides almost complete coverage in Western Europe and growing coverage in the Americas, Asia, and elsewhere. Because it uses radio frequencies, GSM is a wireless platform in contrast to technologies which require connecting one's laptop modem to a telephone outlet to use the land-based telephone network. This means users of GSM can be fully mobile and do wireless computing anywhere without worrying about adapters, telephone jacks, cables, etc. The unique roaming features of GSM allow cellular subscribers to use their services in any GSM service area in the world in which their provider has a roaming agreement. That means the phone you use in France could work in Germany, Australia, Finland, and even China, depending on your provider's roaming agreements. GSM-enabled phones have a smart card inside called the Subscriber Identity Module, or SIM. The SIM card is personalized to you and you alone. It identifies your account to the network and provides authentication, which allows appropriate billing and security. CDMA, or Code Division Multiple Access, is a form of spread spectrum, an advanced digital wireless transmission technique. Instead of using frequencies or time slots, as do traditional technologies, it uses mathematical codes to transmit and distinguish between multiple wireless conversations. The advanced methods used in commercial CDMA technology improve capacity coverage and voice quality, leading to a new generation of wireless networks. In 1992, CDMA technology gained acceptance by the Telecommunication Industry Association and ANSI as an official digital cellular technology. By the year 1995, the first commercial CDMA network was installed in Hong Kong, making CDMA's maturation period less than 5 years, which is a significantly shorter period than for most other communication standards. Consumers will be attracted to the new networks by the promise of increased call quality, range, privacy, and all of the other benefits of CDMA technology, but may likely be convinced by the changes that have been made from the way cellular services have been typically billed in the past. One of the major problems that consumers report with existing cellular service is the ambiguity related to the billing. Aside from being expensive, it is often unpredictable what any particular call will cost. Roaming fees and long-distance fees vary in every location, and it is impossible to tell ahead of time what the rates for any one call will be. The trend with new CDMA networks is to establish a defined local calling area and bill any minutes outside of that area at a constant amount of money, typically 50 or 60 cents per minute. Another important standard that is fostering mobile internet applications is the Wireless Application Protocol, or WAP. Motorola, Nokia, Ericsson, and the U.S. software company Phone.com, formerly known as Unwired Planet, were the initial partners that teamed up to develop and deploy the Wireless Application Protocol. WAP is an attempt to define the standard for how content from the internet is filtered for mobile communications. WAP was developed because content is now readily available on the internet, and there needs to be a way of making it easily available to mobile terminals.